Section 1.6 deals with solving more equations. So we're just going to look at a variety of different types and the techniques that go along with it. So definitely to see some examples here, and then in class on Monday, go over some more. So the first type is polynomial equations. A polynomial just means we have many terms. We're still just going to have one variable, and most of the time we can still solve by factoring, but there's other factoring techniques out there. So our first example is 4x cubed plus 12x squared minus 9x minus 27 equals 0. So there's a technique out there called factor by grouping. We use this usually when there's 4 terms or an even amount over 2, because 2 you can usually just do a GCF. So if there's 4 terms or if there's 6 terms, but that gets a little too involved here. So because we have 4 terms, now there's not a GCF common to all of them. So what we end up doing is we group our first 2 terms together and then our last 2 terms together, and then see if we could factor out a GCF from each set. So of our first 2 terms, I can factor out a 4x squared. What I'm going to have left is an x plus 3. Now my next 2 terms, since they're both negative, I'm going to factor out a negative and a 9. That's the GCF there. What's going to be left over should match this. So let's see, if we do x plus 3, if I check that, we'll get a negative 9x minus a 27. So now we're going to factor out, we have common binomial factors, the x plus 3. So I'm going to factor that out, write it like this. And then what's left over is 4x squared minus 9. So now I'm going to use the zero product property and set each factor equal to 0. So x plus 3 is going to equal to 0, and 4x squared minus 9 is going to equal 0. So this one's pretty simple. X is going to equal negative 3. I could do this 2 ways. I could factor, or how about we just use the square root technique. I'm going to add 9 to both sides. Then I'm going to divide by 4. And then I'm going to take the square root. So x is going to equal, this is where we need plus or minus, square root of 9 over square root of 4. And this becomes plus or minus 3 halves. So my solution set is negative 3 halves, and then 3 halves. Okay, we'll take a look at another example involving polynomial equations. So here we only have 2 terms. Again, I want to try to get everything to one side, so I'll move the 16x squared over by subtracting it. I could still factor out a GCF here, just a 2 and an x squared. So that's going to leave me with an x cubed minus 8. Now there's another technique when we're looking at this part right here would be a difference of cubes. So just generally speaking, if I have some number cubed minus another number cubed, this is going to factor into a binomial and then a trinomial. What goes in the binomial first is just the cube root of each one. So that would just be an a and a b. And then I use the same sign. So when we see a minus here, we're going to have a minus here. What's going to go in the trinomial is I'm going to square the a. So I always teach this by saying we're going to multiply a times a, so that's a squared. Whatever is here, we multiply by itself. In the middle, we multiply a times b. Ignore the signs right now, so we're just going to have ab. Then at the very end, we do b times b, so we'll have a b squared. For the signs, I tell my students to remember the word SOAP. So first we had the same sign, which is right here, same as this one. Then we have opposite. So opposite of a minus would be plus. And then last, we have always positive. So this is always positive here. So SO, same opposite, always positive. If we have a sum of 2 cubes, that means we would have an a cubed plus a b cubed. Again, we would have a little binomial and then a trinomial. Same thing here. We take the cube root of each one, so we get a and b. Over here, we're still going to have an a squared, a times a, and then a times b, and then b times b, so b squared. Follow the SOAP here, so we would have same, but now that would be a plus Opposite would be a minus, and always positive. So we're going to need that for this problem. So I'm going to set 2x squared equal to 0. Then I'm going to set x cubed minus 8 equal to 0. So right here, I'm going to divide both sides by 2. So x squared is going to equal 0. We don't need a plus or minus because it's 0 here, so x is just going to equal 0. So when I go to factor x cubed minus 8, I'm going to make a binomial and then a trinomial. So keep it set equal to 0. What's the cube root of x cubed? X. What's the cube root of 8? 2. I'll fill in the signs later. Then in my trinomial, I'm going to have x times x, which is x squared. In the middle, I do x times 2, which is 2x. And then at the end, I do 2 times 2, which is 4. If I follow the signs for SOAP, I'm going to have the same, so that's a minus. Opposite would be plus, and then always positive. So now I can set this x minus 2 equal to 0, and then I get x equals 2. Then I'm going to set x squared plus 2x plus 4 equal to 0. Now you may think by looking at this real quick that it's going to factor, but it isn't. We have to use the quadratic formula. So unfortunately, this problem is quite long. We'll say quadratic formula here. So let's say x is going to equal the opposite of b, so a negative 2, plus or minus square root. B squared will give us 4 minus 4 times a times c, so that's 1 times 4, so that's 4, all over 2a, so that's 2. So this will become negative 2 plus or minus square root. This is 4 minus 16, so that's a negative 12, all over 2. We want to simplify the square root of negative 12, so that becomes negative 2 plus or minus. We're going to use 4 times 3, and an I is going to come out, so it becomes a 2i radical 3 all over 2. And we can divide everything up here by a 2, so we just get x equals negative 2 over 2 is a negative 1. And we'll get plus or minus I radical 3. So our solution set here is 0, 2, negative 1, plus or minus I radical 3. So there are a couple examples of solving polynomial equations. Seeing some new techniques with factoring, the sum or difference of two cubes, as well as factor by grouping. Okay, next we're going to do a few examples of absolute value equations. And I'm going to start very basic. With absolute value, this means distance from 0. Now the symbols for absolute value, if you remember, something like this. So the absolute value of 3 is just asking you how far away from 0 is 3, and that's 3 units. Absolute value of negative 3, how far away from 0 is negative 3? Well, that's 3 units. Absolute value can even be 0, because absolute value of 0 is just 0. But what if something was missing inside the absolute value, and we have something like this? Well, this really means that x is exactly 7 units from 0. So we could have two possibilities, right? Because there's two sides to 0. This means that x could either equal a negative 7 or x could equal a positive 7. Both of those, if you were to take the absolute value of either one of those, you would get a positive 7. So it's really asking us to find a number whose distance from 0 is 7. So we have negative 7 and 7. So let's try some that add a little bit more to what's inside. All right, so this expression is just representing one big number, but we're going to have to find t in order for the absolute value of that expression to be 6. So this means that 3 minus 2t, so when I go to rewrite this, I no longer need the absolute value bar. So this just means what's inside could either equal a 6, or what's inside, the absolute value bars, could equal a positive 6. Sorry, negative, because I already said positive 6 over here, so this is negative. And then I simply solve for t. Here we're going to subtract 3, so we get negative 2t equals 3. Divide by 2, so 3t equals negative 3 halves. Over here I'm going to subtract 3. This will give us a negative 9. And when I divide by a negative 2 here, t is going to equal a positive 9 halves. So we have negative 3 halves and 9 halves. And you can always substitute these back into the equation to check that what we get here should equal a 6 when we take the absolute value of it. So we have quite a few here to practice. Let's try another one. Now the idea is to rewrite the absolute value into two separate equations, but we can't do it until we isolate the absolute value. So in this case, whenever we see numbers on the outside of it, we need to get rid of it. So here I want to divide by 4 first. So we're going to get 12 divided by 4 is 3. So we get something like this. Now we can rewrite it. So what's inside the absolute value has to be exactly 3 units from 0. So that means 2x minus 5 could equal a positive 3, or 2x minus 5 could equal a negative 3. And then we just continue to solve each one. So here we're going to add 5. So 2x will equal 8, divide by 2, x equals 4. Over here, if we add 5, we get a 2x equals 2. And x equals 1. And again, you still want to check. This one, since we don't have fractions, is going to be a little bit quicker. Here, if we did 2 times 4, that's 8. 8 minus 5 is 3. Absolute value of 3 is 3. 3 times 4 is 12. 2 times 1 is 2. 2 minus 5 is negative 3. Absolute value of negative 3 is 3. And 3 times 4 is 12. Let's try this one here. Let's do absolute value of 7w minus 3 plus 8 is equal to 2. So very much like number 2, I have to get rid of whatever's outside. So I have to subtract 8 from both sides. And when I do that, I'm going to get a negative value here. Well, the absolute value is always positive, or it could be 0. So right here, this side is going to be positive. This side is negative. A positive will never equal a negative. So here we would say no solution, or the empty set. So whenever you isolate the absolute value and it's equal to a negative, it can never equal a negative. Therefore, we could just jump to no solution. Now our next two examples change just a little bit more. Here we see an absolute value equal to an absolute value. And we also have variables on both sides. So what we're going to do is we're going to take the 3x minus 4, what's inside. And we know this is going to come out to be a positive number. So imagine just as a whole number here, we would still set it equal to the number itself and to its opposite. So 3x minus 4 is going to equal 2x plus 1. Or 3x minus 4 is going to equal the opposite of both terms, so a negative 2x minus 1. And then we simply solve each equation. But just, again, take a look at this first step here. We'll definitely try another one after this. So here I want to start by subtracting 2x, so that's going to give me x minus 4 equals 1. Add 4, so x will equal 5. Let's check this real quick. 3 times 5 is 15. 15 minus 4 is 11. Absolute value of that is 11. 2 times 5 is 10, plus 1 is also 11. Over here, I'm going to add 2x, so we'll get 5x minus 4 equals negative 1. Add 4, 5x is going to equal 3. X is going to equal 3/5. Now, this is going to take a little bit more time, but you can use your calculator to check this or take your time and get common denominators. So here, our solution is 3/5, 5. So let's try one more like this. Here we have absolute value of 4 plus x is going to equal absolute value of negative 4 minus x. And let's do the same process here. So I'm going to take this 4 plus x, and it's going to equal exactly what's inside here. Or 4 plus x is going to equal the opposite of both terms that's inside, so that would become a 4 and a plus x. So let's go back to this one and solve it. I'm going to add x to both sides. So we'll get a 4 plus 2x equals negative 4. Subtract 4, we'll get 2x equals negative 8, and divide by 2, so x equals negative 4. Over here, if I subtract x from both sides, I get a 4 equals 4. I lose my variables, and that's actually a true statement, so this would be all real numbers. And that takes over. So not only can x equal -4, x could be any real number. So this wins out. That's going to be our solution for this, all real numbers. And if you think about it, this -4 minus x is just the opposite of this. So when I take the absolute value of opposite numbers, let's say I have an 8, absolute value of -8, they both turn out to be the same thing. All right, the next type of equations we're going to look at is solving a radical equation. So a radical equation has a variable underneath a radical. So we're going to start with something pretty simple like this. So what we want to do, kind of like the absolute values, we want to isolate the radical, and in this particular example it already is. So we want to get rid of this. The way we get rid of a square root or a radical is to square both sides. So now this becomes x plus 10 equals 64. Subtract 10, so then we get 54. So I'm going to still use the square root of x plus 10, but now let's take a look here if we have a -4 equals x, bring in another variable. Well, in this case, I still want to isolate the radical, so we're going to have the square root of x plus 10, and a radical is just another word for square root. And over here I'm going to have x plus 4. But now when I go to square both sides, I now have a binomial over here, so we have to be careful when we square this. So I'm still going to get x plus 10, but remember this means x plus 4 times x plus 4. So we get x plus 10 equals x squared. I'm going to have 4x plus 4x, so we'll have 8x plus 16. So now, guess what? I'm back to a quadratic. So it's kind of good. We get extra practice over previous types of equations here. So I want to bring everything over to one side. So I'm going to still have the x squared here. I'll have a 0 over here. 8x minus x is 7x, and 16 minus 10 is 6. We'll try to solve by factoring here. If not, we'll use a quadratic formula, but this should work. We should do x and x. We try 6 and 1 because everything's positive, so the 6 plus 1 will give us the 7 in the middle. So here x plus 6 equals 0, x plus 1 equals 0, so x equals -6, x equals -1. And remember, it's always good to check your solutions, substitute them back in here, and see which ones work. Actually, we need to do that. Let's erase this. I don't know that I can keep both of them. So let's check our solutions. Let's check when x is -6. So if I get the square root of -6 plus 10 minus 4 equals -6, this will give me a 4. Square root of 4 is 2. Is 2 minus 4 -6? No. So I can't keep this. Let's check the -1. Square root of -1 plus 10 minus 4, will that equal -1? This will give me a 9. Square root of 9 is 3. 3 minus 4 is -1, so I can only keep this. So we call that -6 an extraneous solution. All right, so those were just 2 examples with radical equations. I'll do some more in class on Monday. All right, just 2 more types. Next, we're going to take a look at equations with rational exponents. And what this means is fractions. Our exponents are fractions. So rational exponents, let me just kind of go over a couple of these. When we take a square root of something, we have a little index out here, but when it's a square root, we normally don't write it, but that's a 2, and then the exponent that's here. So what we do is we take our base, and we take the exponent here, that's going to become our numerator, and then the index, 2, will become our denominator. So the square root of x becomes x to the 1/2. If I have the square root of x cubed, that could be rewritten. Again, we have a little 2 out here, x to the 3/2. Now, if we have a cubed root, we definitely see that index. So if I have the cubed root of x squared, that becomes x to the 2/3. So just some ways to kind of look at these here. So let's go ahead and solve. If I have 2 times the quantity x plus 1 to the 2/3 equals 8. What I first want to do here is isolate this part right here. So I want to divide by 2. So we get the quantity x plus 1 to the 2/3 equals 4. Now what I could do is I could raise this to the reciprocal here, because when we raise a power to a power, we multiply, and that will give me a 1. So then I want to raise this to the reciprocal as well. So this will now just leave me with x plus 1, and this becomes 4 to the 3/2. So if I go back, the 3/2 is right here. So this is like telling me my index is 2, so I have the square root of 4 cubed, and I could write it like this. So then x plus 1 now technically this can happen to a positive or a negative, so I'm going to put a little plus or minus sign that's here. So if I take the square root of 4, which is 2, and then cube that, I can get a plus or minus 8. And again, the reason being, if we go back up to the original, I'm actually squaring whatever number is up here, so I can get 2 answers. So that's why we need the plus or minus that's right here. So now I'm going to separate this into x plus 1 equals 8, x plus 1 equals negative 8, so x could equal 7, or x could equal negative 9. So if we check this real quick, using the 7 first, we could do 2 times the quantity x plus 1, actually 7 plus 1, to the 2/3 should equal 8. So this becomes 2 times 8 to the 2/3 should equal 8. So 8 to the 2/3 means we're going to take the cube root of 8 first, which is 2, and then square it, which is 2. I'm sorry, 4. So again, I took the cube root of 8, which is 2. 2 squared is 4, and 2 times 4 gives us 8. Now when x is 9, we're going to get 2, 9 plus 1, negative 9. Make a couple mistakes there. Then we'll have 2/3. That should also equal 8. So this becomes 2 times negative 8 to the 2/3. Now the cube root of negative 8 is a negative 2. So I'll write it this way. And then we're still going to square it. And written this way, negative 2 squared is still a positive 4. So 2 times 4 is still positive 8. So that's why we have to do the plus or minus 8 here, because we could get 2 solutions. Okay, let's try one more of this. So I want to start this one out just like the last one. I want to divide both sides by 2. So we're going to get x minus 4 to the 3/4. Half of 54 is 27. So now what I want to do to get rid of the 3/4 is to raise this to the reciprocal, so this becomes 4/3. That's what I want to do with this side. Now because this numerator here is not even, I don't need to worry about a plus or minus here, because when you cube something, if you cube a positive, it just comes out positive. If you cube a negative, it comes out negative. So we don't have to worry about the plus or minus here. So here we're just going to get x minus 4. Now 27 to the 4/3. This 3 means I'm going to take the cube root of 27, which is 3. Then I'm going to raise it to the 4th. So I get x minus 4. This will give me 81, and x will equal 85. So to check, if I do 85 minus 4, I get 2 times 81 to the 3/4 power equals 54. So taking 81 to the 3/4, I take the 4th root of 81, which actually turns out to be 3, and then I want to cube that. And this becomes 27. 2 times 27 is 54. So I know that that checks. Okay, 2 more examples. Our last type of equations for this section. This is equations in quadratic form. I'm going to start with this one here. Now, we're used to seeing just like a 2w squared equals 3w plus 20. What we still want to do is try to get everything to one side. We're going to try to factor. I'm going to subtract 3w to the 1/3 and subtract a 20. Now, what tells me that this could be in quadratic form is if this middle term, that exponent there, is half of the larger exponent that's right here, and it is. So what we're going to do is we're going to I'm going to rewrite it this way. We're going to have 2 times w to the 1/3 squared, because I want to see something squared, minus 3 times w to the 1/3 minus 20 equals 0. So I'm going to replace the w to the 1/3. How about I just call it an x? So now if I go to replace this, I'm just going to get 2 times x squared. So this whole w to the 1/3 is just x, but then squared, minus 3x minus 20 equals 0. Now I can factor this. So we're just doing a little manipulation here of substitution. I want to factor this. There's no GCF. So we'll have a 2x and an x. Plenty of factors of 20. How about we try a combination of 4 and 5? Let's see if I put a 4 over here, that's an 8x, and a 5 here. 8 and 5 can give me a 3. 8 has to be the negative one. Negative 8x plus 5x will give me a negative 3x. So then I'll set both of these equal to 0. So we have 2x plus 5 equals 0, and x minus 4 equals 0. Now, one thing we have to be careful is when we solve for x, we're not done yet. We have to bring this back in. So here, if I subtract 5, we get 2x equals negative 5. So x equals negative 5/2. And over here, x equals 4. But we need to bring this back in. So if we have x equals negative 5/2, this now becomes w to the 1/3 equals negative 5/2. So how do I get rid of that 1/3? I multiply, or I raise this to the reciprocal, so it's just going to be cubed. So I want to cube this as well. So now this will just leave me with w. I need to cube a negative 5. I'll just attach the negative to the numerator. This will give me a negative 125, and if I cube a 2, that's going to give me an 8. So that's one answer. Then I'm going to have w to the 1/3 is going to equal 4. Again, I want to cube both sides. So this will just give me w. 4 cubed is 4 times 4 times 4, which is 64. So my solution set here is negative 125/8 and 64. All right, and our last example. We have 2x squared minus 3 squared, that quantity, plus 36 times the quantity 2x squared minus 3 plus 35 equals 0. So if you kind of look, we have something squared plus 36 times that something plus 35 equals 0. Now since it's already using an x, let's maybe let u equal to 2x squared minus 3. So now we would just have u squared plus 36u plus 35 equals 0. So it's just, again, a little manipulation we use to make it easier to work with, something that we're used to working or seeing, familiar with. So let's go ahead and make 2 sets of parentheses because there's no GCF. Let's do u and u. Now there's only a couple factors of 35. We could do 5 and 7, but that won't help us get to 36. So our only other option is 35 and 1. And everything's positive here. So we'll get u plus 35 equals 0. U plus 1 equals 0. So u is going to equal negative 35, and u is going to equal a negative 1. But we're not done yet. Now we have to bring back the 2x squared minus 3. So now we're going to say 2x squared minus 3 equals negative 35, and 2x squared minus 3 equals negative 1. So over here, we're going to add 3. We'll get 2x squared will equal a negative 32. Divide by 2, x squared equals negative 16. We need to take the plus or minus the square root. So x is going to equal plus or minus square root of negative 16. And that's going to equal plus or minus 4i. Over here, we'll get 2x squared equals, if we add 3, we'll get a 2. Divide both sides by 2x squared equals 1. Take the square root plus or minus square root of 1. So x equals plus or minus 1. So our solution set here is plus or minus 1 plus or minus 4i. So I'll do a few more from section 1.5 as well as 1.6 on Monday, but hopefully these are enough to get you through helping you with the ALEX module.